What is DevOps? DevOps is a combination of development and operations. It represents a cultural and technical shift in how software development and IT operations are managed. The primary goal of DevOps is to shorten the software development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. Key concepts of DevOps. 1. Collaboration and communication. Definition. DevOps fosters a culture of collaboration between development, dev, and operations, ops teams. These teams work together throughout the software lifecycle, from design to development to production support. Why it matters. By breaking down silos and improving communication, DevOps ensures that software is developed, tested, and deployed more efficiently. 2. Continuous integration, CI. Continuous integration is the practice of merging all developers' working copies to a shared mainline several times a day. Automated tests run every time code is committed to ensure that new changes do not break the existing functionality. Why it matters. CI helps catch errors early in the development process, reducing the cost and effort required to fix them. 3. Continuous delivery, CD. Continuous delivery is an extension of continuous integration. It ensures that the code base is always in a deployable state. CD involves the automation of the release process so that new versions of the software can be released at any time, often multiple times a day. Why it matters. CD allows businesses to react quickly to market changes and customer feedback by deploying new features and fixes rapidly. 4. Continuous deployment. Definition. Continuous deployment is a step beyond continuous delivery. In this practice, every change that passes all stages of the production pipeline is automatically released to customers. There is no human intervention. Why it matters. Continuous deployment maximizes the speed of software delivery, allowing for real-time updates and enhancements. 5. Infrastructure as code. Definition. Infrastructure as code means managing and provisioning computing resources through machine-readable configuration files rather than physical hardware configuration or interactive configuration tools. Why it matters. IAC makes it easier to scale infrastructure, ensures consistency across environments, and allows for version control and automation in the infrastructure setup. 6. Monitoring and logging. Definition. Continuous monitoring and logging are essential components of DevOps. They involve tracking and analyzing software performance and user behavior to identify issues, improve security, and optimize resource usage. Why it matters. Continuous monitoring helps detect and resolve issues before they impact users, ensuring high availability and performance. 7. Automation. Definition. Automation in DevOps is the practice of automating repetitive tasks such as testing, deployment, infrastructure provisioning, and monitoring to reduce manual effort and minimize errors. Why it matters. Automation speeds up the development process, reduces the risk of human error, and allows teams to focus on more strategic tasks. 8. Microservices architecture. Definition. Microservices architecture is an approach to building software systems that separate functionality into independent, self-contained services. Each service is responsible for a specific task and communicates with other services through well-defined APIs. Why it matters. Microservices allow for more flexible and scalable development, where different teams can work on different services independently. 9. Version control. Definition. Version control systems, such as Git, track changes to code and configuration files over time. They allow multiple developers to work on the same codebase simultaneously without overwriting each other's changes. Why it matters. Version control is crucial for collaboration and helps teams manage changes, track history, and roll back to previous versions if needed. 10. Security, DevSecOps. Definition. DevSecOps integrates security practices into the DevOps process. It ensures that security is considered at every stage of the development lifecycle, from design to deployment. Why it matters. By integrating security early, DevSecOps reduces vulnerabilities and ensures compliance with regulations and best practices. Real-life use cases and examples. 1. Netflix. Use case. Netflix is a leading example of a company that has fully embraced DevOps. To manage its global streaming service, Netflix uses microservices architecture and continuous delivery practices to deploy thousands of times a day. Outcome. This approach allows Netflix to quickly roll out new features, fix bugs, and scale its services to meet user demand. To Amazon. Use case. Amazon uses DevOps practices to manage its vast e-commerce platform. The company's ability to deploy code every 11.7 seconds allows it to stay ahead of the competition by delivering new features and improvements rapidly. Outcome. Amazon's DevOps approach has contributed to its agility, enabling it to handle massive traffic, especially during peak shopping periods like Black Friday. 3. Etsy. Use case Etsy, an online marketplace, faced challenges with slow deployments and frequent downtime. By adopting DevOps practices such as continuous integration, continuous delivery, and automated testing, Etsy improved its deployment frequency from once a week to 50 times a day. Outcome. This transformation reduced downtime and increased developer productivity, resulting in a better user experience and higher sales. 4. Spotify. Use case. Spotify uses DevOps to manage its music streaming service. The company adopted a microservices architecture, allowing different teams to deploy their services independently. Spotify also uses continuous delivery to update its app frequently. Spotify's DevOps practices enable it to innovate quickly, respond to user feedback, and maintain a high quality service across multiple platforms. Benefits it's 1. Faster time to market. DevOps reduces the time it takes to develop, test, and deploy new features, allowing businesses to respond quickly to market changes. 2. Improved collaboration. By breaking down silos between development and operations teams, DevOps fosters better communication and collaboration. 3. Increased efficiency. Automation and continuous integration/delivery reduce manual tasks, minimize errors, and increase the efficiency of the software development process. 4. Better quality and reliability. Continuous testing, monitoring, and integration of security practices ensure that the software is of high quality and reliability. 5. Scalability. DevOps practices, such as microservices and infrastructure as code, enable organizations to scale their infrastructure and applications more easily. Challenges of implementing DevOps. 1. Cultural shift. Moving to a DevOps model requires a significant cultural shift. Teams need to embrace collaboration and communication, which can be challenging in organizations with a history of siloed departments. 2. Complexity. DevOps introduces a range of new tools and practices, which can be complex to implement and manage. Organizations may face challenges in integrating these tools into their existing workflows. 3. Security concerns. While DevSecOps addresses security, the fast pace of DevOps can sometimes lead to security vulnerabilities if not managed properly. 4. Legacy systems. Integrating DevOps practices with legacy systems can be difficult, especially if those systems were not designed with modern development practices in mind. Conclusion. DevOps is a transformative approach that has reshaped how software is developed, deployed, and maintained. By fostering collaboration, automation, and continuous improvement, DevOps enables organizations to deliver high-quality software faster and more efficiently. While there are challenges to implementing DevOps, the benefits far outweigh the difficulties, making it a critical practice for modern software development.